Hi guys, so today we're going to look at covalent bonding, and I've got three molecules over here to start off with. Chlorine. Show the bonding that takes place in chlorine. Now chlorine is a diatomic molecule, so it's written as Cl2. It's sometimes also shown as Cl with a single bond, Cl. And what we're going to do then is transfer that information into a dot and cross diagram. So the single bond over here, you should all know, means a pair of electrons that are being shared. Okay, that is what a covalent bond is. It is the sharing of a pair of electrons between atoms. Okay, the nuclei of each atom. So let's do that then. So we've got chlorine over here. Now chlorine, we're only going to show the outer electrons only. So show outer electrons. And so chlorine has 7 electrons. So 1, 2, 3, 4, 5, 6, 7. And then the other chlorine has 1, 2, 3, 4, 5, 6, 7. And so these ones in the middle are the shared pair of electrons, or that single bond over here. Okay, this is the covalent bond. And sometimes you might also see it like this. So just let's try and draw the Venn diagram version of this. So here is the Venn diagram, and this is sometimes how it's also shown. And what you need to do is the same thing again. So you have your 7 electrons, so your 6 over here, and one of the electrons is being shared. Okay, so they still go and reach that definition of having 8 electrons in the outer shell. And let's do another 8. So we've got our 7 over here as well. 1, 2, 3, 4, 5, 6, and 7. So you can see that both of these have 8 electrons, both atoms of chlorine. Okay, and so we have our covalent bonding for chlorine. Now let's look at the next one, which is that of oxygen. Now oxygen, you need to know, has a double bond structure. So oxygen is written as O double bond O. 2 lines means 2 pairs of electrons. So if you want to get into the habit of good practice, well, just look at the lines and represent them as 2 electrons each. So there's 4 electrons being shared between each oxygen atom. So let's do that then. Oxygen and oxygen. And let's do 4 in the middle. 1, 2, 3, 4. Now, these 4 electrons, okay, 2 of them are from one oxygen atom and 2 of them are from the other oxygen atom. Oxygen is in group 6. It's in group 6. So it has 6 electrons in its outer shell. So let's do the remaining 6 from each of these. So let's do this on this side. 1, 2, 3, 4. Okay. So now we've got 1, 2, 3, 4, 5, 6. And we have altogether 8 for this oxygen atom, 2, 4, and then the 4 in the middle, which is 8. And then again, let's try it for the next one. We've got our 2 in the middle, then you've got 4 on the outside as well. 1, 2, 3, 4. Okay. Now let's show this as a Venn diagram. And this time we're going to have 4 again in the middle. So you get the idea now. Cross, dot, and then you have your dots on either side to complete, well, let's make this X's to complete it and have some consistency. And we've got the oxygen and the oxygen atom for each. And that's it. There you have it. You've got your double bond over here. And sometimes you're given a triple bond. So a triple bond example is nitrogen and carbon monoxide. Now nitrogen is written as N2. Again, it's a diatomic molecule. It's also got the structure N triple bond N. Now, if you use our method from before, we then know that we have 3 electrons, or 3 pairs of electrons in the middle. So let's make that N. And then we've got X dot 1 pair, X dot 2 pairs, X dot 3 pairs. And so you've got your 6 electrons in the middle. You know you've got 6, so each atom still needs 2 on either side to complete the 8 octet rule. And so you have X, X on this side and dot, dot on this side. You know that nitrogen is in group 5, okay? So it has 5 electrons in its outer shell. So if we just do that, I can confirm that we've got 1, 2, 3, 4, 5 from one nitrogen, and then we have 1, 2, 3, 4, 5 for the other nitrogen. Okay, and there you have it, some covalent bonding for you.